What's poppin' YouTube, it's your boy Andy, and in this video we are going to solve another coding interview challenge from LeetCode, which is called word subsets. It's a medium one, so it really should be no problem to us. So, we are given two arrays A and B of words. Each word is a string of lowercase letters. Now, say that word B is a subset of word A if every letter in B occurs in A, including multiplicity. And we have an example, WRR is a subset of warrior, but is not a subset of word, right? Because WRR has one W and two Rs, which warrior has, but word only has the W and one R. Now, say a word A from A is universal if for every B in B, B is a subset of A. There are way too many A's and B's in this statement, but trust me, once we get to example number one, you will definitely understand it. So let's jump into the examples. And here is the first example. So in the input, we have, let's say, 5 words, which are Amazon, Apple, Facebook, Google, and LeetCode. And in the B array, we have only 2 words, each of them consisting of one letter. So they are E and O. And let's see why the answer is Facebook, Google, and LeetCode. Well, we have to get all the words which have the letters E and O in them. Amazon has O, but it doesn't have E, so it's not going to be in the final answer. Apple has E, but it doesn't have O, so he's not going to be part of the final solution. Facebook has both E and O, Google has both E and O, and LeetCode obviously has both E and O. So those 3 are going to be part of the final solution. Let's take another example. On example number 2, the set A remains exactly the same, but the set B consists now of 2 words, and they are E and O. So we are going to look in the set A and see what are the words which contain E and the letter O 2 times. And of course they are Facebook, so here is Facebook, and Google. And that is going to be our output. Now hopefully you have understood the problem. If you didn't, that's cool. Take a little bit longer to understand both the examples, because we are going to jump now into the solution. Now, as you've already probably noticed, in a word, the order of its letters doesn't really matter. What's important is what are the letters and each of them how many times appear. For example, if we take our word, which is Facebook, what is important in this word is that the letter F occurs exactly once. The letter A occurs exactly once. The letter C, 1 time. The letter E, 1 time. Letter B, again 1 time. The letter O occurs twice. And the letter K occurs 1 time. This is exactly why the word Facebook is going to be equivalent to this word, ACEFOOKB, because their letters are the same. Let's take, for example, Google. If I take the word Google, what is important to me is that in this word, the letter G occurs 2 times, right? So I am going to count each letter, how many times it appears. So G 2 times. Letter O is going to appear also 2 times, right? Here. Letter L appears 1 time here, and letter E appears 1 time too, right? So if I take a look at Google, I am actually going to take a look at this dictionary, hash table, or however you want to call it, and I want to see if this dictionary is part of something bigger, right? So Google is basically a subset of some word if its dictionary is part of that word's dictionary. And for example, Google is a subset of this word, OOLGLGE. Why is that? Because Google's dictionary, as we said, is G 2 times. Alright, so G 2 times. How many times does G appear in this word? Well, 2 times 2. So everything's fine. Then, let's take a look at O. O appears here 2 times. How many times does it appear here? Also 2 times. So 2 times here, 2. L for 1 time, and E for 1 time. So this is Google's dictionary of letters. And for this word, so G 2 times, O 2 times, L 2 times, and E 1 time, right? So this dictionary is part of this dictionary, because if you take a look at each letter, the number of times this letter appears is less or equal than the number of times the same letter appears in the second words dictionary, right? So 2 and 2, 2 and 2, 1, which is less or equal than 2, 1, which is again less or equal than 2, and of course so on and so forth. And the brute force approach is going to sound like this. So this is our brute force approach, right? Well, we are going to try out each word in A, right? So for each A, which is in the A set, we have to see if this word is universal or not. And for this, we have to check if each word in B is a substring of this word A. So basically, we are going to iterate through each word in B. And if B is a substring of A, I am going to use this notation for substring. Everything's fine. But if it's not, we know that we have to return false, right? And we know that A is not part of our solution. When this for loop finishes and we are here, we know that A passed the test, and each word of B is actually a substring of A. So we can do something like here, we can say answer dot insert A. So we are inserting that word into our answer. Of course, in the end, this answer is our final solution. But now the question is, how can we quickly check if B is a substring of A? Well, remember the dictionaries. We are going to take each word in the input and transform it into a dictionary. Alright, so for this example, we are going to take each word in A. First word, it's Amazon. And for each word, this is pretty simple. We are going to iterate through each of its letters and just increase their counter into the dictionary, right? So initially we will have a dictionary which is empty. On the first iteration, we have letter A. So we insert A with its counter, which is 1. Then we will have the letter M. So we insert M with its counter, which is 1. Then when we have the letter A again, we are going to delete this one, and it's going to be transformed into 2. So we basically increment it. Then we have Z. So because it's new, we insert it with its counter 1. Then we have O. Again, same story. And then of course we have the N. So this is same story. So we are going to take set A and set B and do this for each of them. So now each word is a dictionary. And then, when applying the brute force approach, to check if, let's say here, to check if B is a substring of A, we are going to perform at most, worst case, 26 comparison, right? So it's going to be something like big O of 26. And why is that? Obviously, in each of these 2 words dictionaries, we have at most 26 entries, right? For each letter of the alphabet from A to Z. We are going to take each letter and compare the counter. Alright, but what is the time complexity of this approach? Well, this is exactly why we have said this is going to be a brute force approach, because we basically try out each pair of words. So for each A, we are trying each word in the B. And for checking if that word is universal for each word in B, we are going to make 26 comparison. So this is big O of n squared with a constant, which is pretty high, of 26, right? So this is not actually a good time complexity. What can we do in order to improve this? Well, this is simple. For each word in the A set, it's not necessary to iterate over and over again through each word in this B set. We can make something, we can do a pre-computing, which will make our checking if the current word in A lot easier. And let's see what I mean by that. Let's take that second example. And let's take a look at this B set, right? It consists of two words, which are E and OO. Perfect. Now, when trying out each word in the A set, why checking each of these words when the dictionary of E is going to be one entry E, which appears one time. The dictionary of OO is going to be one entry, which is O, and it appears two times. Instead of taking each word in A and checking its dictionary with each dictionary in B, we can initially merge these dictionaries and make a bigger one. So our dictionary is going to be E one time and O two times. So now, all we have to do is that for each word in this A set, we are going to look only at the big dictionary and compare with that dictionary, right? There's no need to try out each of these words' dictionaries when we have a bigger merged one, which is going to make the checking a lot easier. So now what is going to be the time complexity? Well, for each word in the A set, we are going to perform at most, in the worst case, 26 comparison, right? So at most 26 comparisons. And now we basically obtained the right time complexity, which is almost linear, but with a constant which is actually pretty high, right? So we are going to have n crossed 26. This is our finally time complexity, right? So just as a recap, let's write here again. What was the step number one? Well, let me erase this. All right, perfect. So for a recap, step number one is going to be to transform each word into its dictionary. Step number two is going to be to take the dictionary of the each word in the B set and merge them together, right? So merge the dictionaries in B, and then after we have a final bigger dictionary, the third step is to try out each word in A. So for each A in the A set, and check its dictionary, right? So the dictionary of this word, if it is part of the dictionary of the whole B set. And we are going to perform this in at most 26 comparisons. Alright guys, so this is the solution. Let's now jump into writing the code. And now, of course, let's jump to everyone's favorite part, which is writing the code for the solution, right? So I'm going to code in C++. As you can see, I have the function word subsets, and those sets from the input A and B are given as vector of strings. Alright, now, step number one is, as we've said, we are going to go through each word from the B set, get its dictionary, and then merge those together, right? Now, in C++, a dictionary is basically an unordered map. So, let's first of all go through each word in B. So, for string B, in B. And what I'll do here is that I will define an unordered map, which is going to be from char to int, all right? Remember, for each character, how many times it appears. And let's call this letter counter, all right? Now, for this word, I'm going to iterate through each letter. So for char C in B, and all I have to do here is just letter counter of C plus plus. All right, what I want you to notice is that each time I go to a new word, so to a new string, this unordered map builds over and over again, right? So it is going to be initially empty always, which is very well. Now, for this word, I've built its dictionary, so I have to use this in order to merge it to the dictionary of the whole set. But what is the dictionary of the whole set? I have to define it. So I will go and unordered map of char and int, and let's just call it total letter counter, all right? And when I know this letter counter, all I have to do is go through each character. So for char C, starting from A, less or equal than Z, and C++, and in total letter counter of C, I have to update it with the maximum between its value and this value. So letter counter C for this word, right? When we finish this for loop, we basically know the dictionary for the whole string B. Now all we have to do is try out each word in A. So of course for string A in A, let's build its dictionary. So because I'm lazy, I'm going to copy paste this code, but you should never copy paste your code. It's like that prescription on medicine or something. And of course, don't do this during interview questions. But for now, just for the fun of it, so letter counter, we are going to use the same name, is initially empty every time for each different word A. And again, for char C in this word which is called A now, we are going to increase the letter counter. Now, we know the letter counter, and what we have to do now is to check if the total letter counter dictionary is part of this dictionary, because that will mean that every word in the B set is going to be part of this word. So this word is universal, right? For this, we are going to write a function, and let's call this function is part of, and is part of. So total letter counter has to be a part of letter counter. If this is true, all right, this function is going to return false or true. If this is true, that means we have to insert this word A into our answer. But what is our answer? Well, we need to return a vector of strings, right? So let's define here a vector of string, and let's call it universal words actually. So universal words, and each time this is true, the universal words are going to, we are going to push back this word which is A, right? So two universal words push back A, and of course in the end we just return universal words. Now all you have to do is write this function which is part of, and we can do this right here. So we are going to have bool is part of, and we will use unordered map of char int reference. All right, very careful with this reference because we don't want to copy all the information in that unordered map. I mean, of course there are only 26 entries, but still it's a lot of useless iterations and operations, and we are smarter than that, right? So let's take this unordered map A with another unordered, that's right, char integer reference again and B. And all we have to do here is go through each letter, so char, not int, from A. C is less or equal than Z and C++, the language you're using, right? So all we have to do here is, if A of this C is less or equal than B of this C, that means everything's fine. But if it's not, so the letter C appears in A more than it appears in B, that means we have to return false right away. Of course, at the end of this for loop, we are going to return true. And this is it. We can run the code, very probably to have bugs, but let's see. So it's judging. Okay, all right. So for the first input, it got the right answer. Let's submit it. Let's see what's going to happen. Okay. And nothing happened. Okay, nothing happened because I'm in full screen mode. Alright, so, okay, alright, perfect, alright. So, as you can see, it's a success. The memory is less than 8%, faster than 5%, so these are pretty horrible stats. But you can optimize this a lot. First of all, you can use vectors instead of unordered maps, and there are a couple of things you should do, which of course is going to be your homework. So, as always, if you enjoyed this video, don't forget to subscribe, hit the like button, share it with your friends, and I can't wait to see you on the next one.